Hello everyone, I have a question for you. Do you know what is the distance between Sun and the Earth? Well, most of us don't know the answer. So let's just check it, okay? So the distance between Sun and the Earth is 150.01 million kilometers. And this is a huge number, right? But are we sure that the distance between Sun and Earth is exactly 150.01 million kilometers? Well, or is it approximate value just to understand how far the Sun is from the place of Earth? So this is nothing but an exact depiction of how approximation works. Well, we can say that it is more than 150.01 million kilometers that the distance between Sun and Earth there is, but there's an issue. It can be also 20 kilometers less, or it can be also 500 meters more. It can be anything. So in such cases, what we need to know is that in most of the cases where we find uneven numbers or distances which we can't exactly measure, we use a process called as approximation. In first case, if we know that root of 16.35 is very difficult to understand or difficult to find out, but we know that the root of 16 is nothing but 4. Also in the second case, e raised to 1.003 is very hard to find out by usual methods. So we know that e raised to 1 is e, but it is very hard to find out what is e raised to 1.003. So in such cases, what we'll see is we can use differentials or differentiation, and we can easily find out what is the approximate value of such functions. But we don't want to juggle on different topics and different ways to find out. So I'll give you the direct example or the direct formula to how to find out what is the approximation. So what is the approximate value of a function f of x plus a? So in such cases, we can go into the previous slide and we can say that 16 is nothing but x, and the variable change, which is a, in this function we can state it as 0.35. And if we look at the approximate value to find out, we can state it as f of x plus a times f dash of x. So we have known that from the previous slide that f of x plus a is equals to f of x plus a times f dash of x, and we have seen a question also which is under root of 16.35. So let us take that same example and try to understand how can we solve it. For example, if your question is root of 16.35, and now in this case, can we say this question can be termed as 16 plus 0.35? Yes, we can. And if we compare it with f of x plus a, we can say that x over here is nothing but 16, or rather root of 16, and then we can immediately take the values and put directly into the formula. So here, so root of 16.35, we can also state it as f of x. So what is f of x? F of x is nothing but root of x. So x is 16, so we take plus 0.35, which is again the a value over here. So a is nothing but 0.35, so into f dash of x. Now what we have to do is we have to differentiate root of x over here. Now why do we have to differentiate? Since x is 16, so the f of x value is going to be root of x. So we know that the differentiation of root of x is going to be 1 upon 2 root x. So we can say that root of 16 is nothing but 4 plus 0.35 times 1 upon 2 root of x, but x is 16, so we again have the same value over here. So we have 4 plus 0.35 divided by 2 times 4, which is going to be 8. So your final answer is going to be 4. Now you can directly do this, or you can take one more step and simplify it further. So I'm going to simplify it further. 0. So again you have to take a carry forward a 0, then you have 4, and then you have 3. So you don't need much more decimals. So up until third decimal it's fine. So your final answer is going to be 4.043. So for that, I'll just provide a screenshot over here of what is the exact value through a calculator, and it is pretty much the exact same value or the exact approximate value. Now we'll take a few more questions from our textbook of CBSE and state. Now, differential equations or the approximations using differentiation is not only limited to finding the square roots, cube roots or the fourth roots, or just for finding distances. It is also can be used for finding what is the change in volumes. It can be also be used to find out what is the change in surface areas and various other purposes. So one such question is, find the approximate change in volume V of a cube with side s meters caused by increase in side by 2%. So there are a few key information in this question, and this is fairly easy question. So we'll try to find out how can we do this. So first they are given that the volume is V of a cube with side s. So you can directly say that V is equals to s cube, right? So in this way we need to find out what is the exact change. So can we say that the old volume was VO equals to s cube, and the new volume will automatically be Vn, which is equals to s plus 2%. So we can directly say it is 2 upon 100 times s. So this is 2%. So this will be the new volume, and here the application of differentiation or the differentials can be used in finding out Vn. So what is the approximate change? Change is nothing but the new minus old volume, isn't it? So we can find out, if we find out what is Vn, then we can easily find out what is Vn minus Vo. So let's try to find out that. So if we take s plus 0.02 s cube in terms of f of x plus a, then we can say that x is equals to s and a is equals to 0.02 s, isn't it? So your answer will be f of x plus a. From the formula itself, it is going to be f of x plus a times f dash of x. Now f of x will be what? S cube, and a is nothing but 0.02 s times f dash of x. So since f of x is s cube, f dash of x is going to be 3s square, isn't it? So your final answer is going to be s cube plus 0.06 times s cube. So this is your answer for what? Vn. So this is your answer for Vn, so which is the new volume. Now if you go down further the road, we have Vn minus Vo, which is your final answer. So what is Vn? It is nothing but s cube plus 0.06 s cube. And what is Vo, or rather the previous volume? It is going to be s cube. So we can cancel out s cube and s cube. So your change, or rather approximate change, approx change is going to be 0.06 s cube in the unit cubes. So this is your final answer. Now we'll see another question. So next question is very easy. It says that 4.01 whole cube. We know that 4 cube we can easily find out, it is going to be 64, but since it has 0.01 at its start, after its decimal points, it is going to be fairly complicated to find out, but with differentiation or differentials we can easily find out. So we can write this example as f of x, we can write it as 4 cube. We can write a as 0.01, and since we have that, we can directly place on to the values, and f dash of x will be 3 times 4 squared. So we have 4.01 whole cube, which is going to be equal to 4 cube plus a times, or rather what is a? 0.01 times f dash of x, which is 3 times 16. So 3 times 16 is what? 16 times 3 is 48. So you are going to have 4 cube, which is 64, plus 0.01 01 times 48 is going to be 0.48. So your answer is going to be 64.48. So in this way you can easily find out what are the approximate values for various examples, and in such way we are going to find what is the value of the next question, which is cube root of 63. Now in this case we can write 63 as 64 minus 1, and in this question our knowledge is going to be a little bit tested. So for easy understanding purpose, what I will do is I'll just write this as 64 plus, in bracket I'll take minus 1. So it is easy to understand, so I'll explain why I have done that. If I write f of x plus a, you will say that we need a plus sign over here in between, isn't it? So that is why I have written it. You can directly write f of x minus a and you can change the formula for minus, or you can change it just by doing a negative sign at the front. So it is going to be f of x plus or minus as you need f dash of x. So we'll see what is f of x. So f of x is nothing but cube root of 64. So f dash of x, what it will be? 1 upon 3 raised to 64 upon minus 2 upon 3 raised to minus 2 upon 3. And what is a in this case? A is nothing but minus 1. So we have directly substituted the values, and now we'll try to find out what is the exact value. So cube root of 63 will be, what is f of x? F of x is cube root of 64 from here, this step. Now since we have written plus, we can directly write plus times a, which is minus 1, times f dash of x, which is 1 upon 3 raised to 64 raised to minus 2 upon 3, isn't it? So now we need to juggle upon few numbers. So cube root of 64 is easy, 4 plus minus 1 upon 3, everything raised to 64 raised to minus 2 upon 3, right? So in this case we can just simplify this further. So I'll just write it down over here in a column. So 64 raised to 1 upon 3 raised to minus 2. You can also do this in this easier way. So 64 cube root will be what? 4. So 4 raised to minus 2 is what? 1 upon 4 squared, isn't it? So it is going to be 1 upon 16. So you can directly say it over here as this whole term is going to be 1 upon 16. So in this case it is going to be 4 minus 1 upon 16 times 3 is 48. So 1 upon 48 you just need to find out. So minus 4 minus 0 point, so you have carried a 0, so again you have to get a 0, and then you have 2. So your final answer is going to be 3 point. Now since it is 0.02, you can say directly it as 9 and 8. So this is your approximate value for the cube root of 63. Thanks for watching and see you in the next video.